Can you hear me? Yes, good. So let me just introduce myself. I'm Mark Hare. I am IBM's leader in the region for data center services. I have about 25 years of experience in the field working for IBM all this time. So I've seen many changes in the data center and the IT industry during that time. And what I want to do is obviously share with you, where this all started from, and give IBM's view of where data centers are going to in the future from a practical point of view, and give you an insight from an innovation point of view where we think data centers will be in 5-10 years from now. So not many people realize that IBM built data centers. IBM is traditionally associated with originally PCs, laptops, server, storage and software. And to many people, the fact that IBM built data centers is quite a surprise. And going back in history, we built the first commercial data center back in 1960. It was a data center we built for American Airlines at the time, and it was housed what became the first real-time business system for any industry outside of government. And it was key because I think this was the starting point for everything that we see and do nowadays. Now, looking around the room, there are people from various ages, and probably some of you won't be able to remember the time when you couldn't book a flight on the website. But back in the 60s, in that stage, it would take you at least 90 minutes. You would have to go to a travel agent. A travel agent would have to phone American Airlines right the way back to the head office. And in the back of the head office in American Airlines, there were literally people sat round one piece of paper, and on that piece of paper was every seat in the aircraft, and they would put a pencil tick in that box and put your name in that box, and then you had that seat reserved. That used to take 90 minutes at the fastest it could do. Obviously nowadays we all go online, we book our tickets, we book our seats, we book our food, and it's all done. And it's something that we take for granted now, the fact that both businesses and governments have to make available these services to their clients and to their citizens 24 hours a day, 7 days, 365 days a year. So as part of our engagement with our clients and with the market, we do regular surveys at various levels with CIOs and CEOs. And the chart that we have here is the result of a survey that we do with CEOs. And this is something that we do every 2 years. Now, what you may be surprised to see, and I certainly was surprised to see the first time I saw it, that if you look over the 2-year period, every 2-year period, slowly, technology factors have gone up to the list, to the point where in 2012, technology factors is the #1 issue and concern for CEOs. I wouldn't have been surprised at CIOs having this on the top of their list, but now it's very clear that the CEO and the whole business is focused on technology factors. And within IBM, we break these factors down into sort of 3 key areas. One is cloud computing, which I'm sure that we're all aware with the implications. Analytics. So many organizations now have so much data. They're trying to use this data in a useful manner to understand how their clients work, understand patterns, understand what's going to happen in the future. And the key thing down at the bottom is social and mobile communications. And this is the bit that's really driving the industry to have this rapid increase in change. With my phone now, I could stand here if I wanted to, check my bank account, I could book a flight, I could pay my water bill, I can pay my electricity bill. All these things that we as users and citizens take for granted, we have to now consider how do we support these, because these are services that we have to continuously provide 24/7. So my interest within IBM is specifically the data center. And when I talk about the data center, I'm talking about the building that you put all your IT into. And we have to look at how this change in the way of technology is moving forward, how we accommodate this in the data center. Because it's all very well and good having the highest available systems in the world and having live live environments, but if the foundation or the data center that you put it in is not resilient, you're going to have issues. So when we look at cloud computing is really the result of virtualization. And virtualization has allowed us to put many instances of server and applications in a very small footprint. So in the old days when I was first doing this, you would have many racks with 1 kilowatt or 2 kilowatt loads. We now have these highly populated racks, maybe with blade servers, which consume a huge amount of energy and really affect the design of a data center. In the old days, you could build a data center, you could put some cooling in, you could put some power in, and you would never need to really worry about it. But in the current environment, with the technology we have today, the stresses that puts on, data centers are becoming very purpose-built, very highly specified designs and infrastructures. Analytics is really having the same effect as cloud is. Lots of storage, as you can see there, from terabytes to zettabytes of storage that's being used by organizations that are having to process this. Again, very large demands on the data center in terms of power density, and in fact, in some cases, just purely the weight of the systems that we have to worry about. And finally, as I mentioned, mobile and social. We now have to look at how we get much more data in and out of the data center. The processing is not so much within the data center now, it's going out to all the end clients and all the end users, and we have to do this in a safe and secure manner. So, when we look at the data center now, I think most organizations are trying to virtualize. So in the old days, within the data center, you may have a new project for a new system, and that would result in a couple of racks of equipment going into the corner. That would be there. You'd then get the next project, and that would go next to it, and so on and so on. It's different now. Modern organizations are putting in their own private clouds. They're putting a cloud infrastructure, and all they simply do is spin up more VMs. So as projects come along, it fits within the same technical footprint, and so you have this much denser organization of your compute resource within the data center. And I think the key we have here is the fact that most organizations we see are going to a hybrid cloud. Private cloud on its own is expensive. It doesn't give you the flexibility. Public cloud is often regarded as unsafe, insecure. So we're now having a balance, and we in one of our recent surveys of CIOs, 73% of all CIOs believe by the end of 2015 they will have a hybrid environment. And what we mean by that is they will have their own private cloud for the very sensitive key systems within their own data center. But for non-essential items, maybe it's their social media interaction, maybe it's their development, maybe it's their test platforms, they will actually move out to a private cloud. So you will have that balance. Core elements still staying within their own data center, and the use of cheap, discardable, consumable processing outside for non-key areas. So we have now a situation where clients are having to build much more sophisticated data centers to allow for this denser computing. So if we assume that everyone is going towards their own cloud-type data center, you've got to ask the question, what does a cloud data center look like? And what it looks like physically will be completely different depending on the organization that you are. You know, this is Apple's data center, a huge facility which they're going to run their cloud from. But if you're a small department, ministry, or commercial organization, you know, your same cloud footprint is much smaller. But the key point I want to make about these two, although they're vastly different in size, they do have the same key attributes. They need to be scalable. And the reason that even we as IBM, we can predict where technology will be 3 years, 5 years down the line, because we own the roadmap, we determine the technology. But we don't really know beyond there where science is going to take us. And when you factor that when you invest in a data center, it's probably at least a 10-year investment. So how do you plan what's going to be in that data center in 10 years' time? And the answer is we can't. Even we cannot predict it. So what we have to do is got to make sure that whatever we build is scalable. So what you put in on day one, you'll be able to adapt as you go forward and grow. So when you look at that, and when we look at what are the main elements of a data center, when you build a physical data center, 60% of the capital cost is around the power and the cooling. In recent years, when the first thing you would think about when you were about to design or build a new data center was, how big does it need to be? How many racks do I need? But when you look at this breakdown of the cost, probably that element around the physical size of the building is only 10% of the capital cost. Where the real money comes from is the power and the cooling. So what we need to do is focus on how much power you need in this data center. And this is a real example if I look at the graph. So here we have a data center with a planned 10-year life. And the green curve represents how much the client thought his power consumption would go through that 10-year period. So in the old days, traditional build would be, right, okay, we know what it needs to be after 10 years, so let's build it now for that 10-year capacity. Again, you're wasting a massive amount of money in that capital plant that you won't need till later in the stage. So this is an example of a data center where the client wanted to start at 6 kilowatts a rack. So in day one, we provide him with the infrastructure, provide 10 kilowatts a rack, but we include a foundation infrastructure within that design so that when he gets to year 4, he can just expand and upgrade it with some incremental cost without completely rebuilding the data center. This step process is probably typical of how we think a data center will go over its life. Two major upgrades to increase the power. So what we are doing now from an IBM perspective, when we work with you to build a data center on day one, we're looking at what the end game, what the target power will be, and we're making sure that we put in day one the foundations to allow you to have that seamless growth as it goes. And of course it also gives you the flexibility should technology change so that actually we have a breakthrough in semiconductors or processors, so we find a magical new processor that uses less power, then great. You don't have to make those investments at a later time, so it gives you that flexibility. So we have a whole set of projects and solutions for clients who have different requirements, specifically around size. We have something which is more the traditional data center, which is the sort of 0 to 50 rack size. Again, the key point of view, you see the theme through all this, they're modular. So this would be a more traditional data center in an existing building where we can go and provide this modularity. We can put it in day one. It uses all the techniques around cold aisle, hot aisle containment to make sure it's as energy efficient as possible. But the key thing there, it gives you the flexibility. The second one is the larger data center that we're seeing, and these are for organizations that may become service providers, that may be telco providers. And we are also seeing this some from a government point of view as well, and I'll cover that on the next slide. Another key area are these the quality of the picture's not too good, but that is almost like a shipping container. These are literally portable modular data centers for organizations. There may be oil and gas exploration where they want to move their assets around. So we have this offering. And the final one in the end is the high density zone. High density we associate with cloud. Cloud is high density computing. And this is a self-contained unit that you can put into an existing data center. So if you have an existing data center, you don't want to do a complete refurbishment because perhaps you have some legacy equipment that you can't change. This is an ideal solution for going in and sitting in an existing data center. So before I moved, and let me explain, I now live in the region, I live in Dubai, but before that I was based in the UK, and I was an advisor to the government there in Scotland on their data center strategy for the government. And one thing that was very clear, that there was a need for some central functioning government to start building large-scale data centers for a couple of reasons. Building this large scale, you can get the resiliency. You can get high resiliency because they are purpose-built buildings. And it allows you to work with all the different departments and ministries to offer a service to them. So it's not necessarily everyone moving into this data center, it is a support service to those things, whether it be DR, maybe it's a development and test cloud that you make available to them, or central service that you can do that. So we found that for most governments, this is the way that they're going. They're building 2 or 3, let's call them mega centers or mega data centers. And again, we have the same modularity in terms of the approach to the design. So in phase one, you will just have one module. So we build, you see there's a central shared area here for offices, NOCs and SOCs, and then we just add modules on almost like a brick fashion. So as the facility grows, we can put in this expansion to grow. We find that this is incredibly popular with the larger organizations. And the reason is that it's popular is really from the finance point of view. There is an initial 10% premium uplift to do this, because on day one, you have to make sure that you put the foundations in for the end game. But once you've done that, you're finding that, we've found that with customers, we've got tremendous saving on capital. 40% reduction on capital cost because you're only building what you need at a time, and 50% on operational costs because you're only operating the spaces that you need to do. So this ethos and philosophy, we just stay throughout all our products, whether it's a 10 rack or whether it's a 1,000 rack. It's the same thing, and it's a tried and tested methodology where you have the ability to scale up. So you may start with very low power densities and increase the power density, and also scale out in terms of footprint. So as you have to bring on new services, and as your online presence increases, to allow those extra services to run. So how do we engage? I've talked about there is this wide spectrum of data centers that are out there and both needed, but we have a common process of working with clients. The key bit is how we do our assessment. I think this is a key bit with any organization, is understanding what your requirements are. So it's sitting down with you, understanding where you think you're going. We provide input as a technology company, because we can hopefully give as good insight as anyone else as to what will server roadmaps, what will storage roadmap look in the future, how will servers of the future be cooled? Will they be water cooled? Will they be air cooled? So this is a service we provide, and out of this will come a very high level statement of requirements about what you need in terms of a data center. We then have a design. So actually within IBM we have centralized areas of expertise who are mechanical engineers, civil engineers, and electrical engineers that can help put that statement of requirements into design. And we can do it several ways. We can do the whole thing for you, or we can help to support you if you need to go to RFQ or RFP. We can help create those documents. And if necessary, we can actually do the work as well. So we don't pretend we're not a builder, but we work with key partners in the area to be able to provide a turnkey solution. So we will take accountability for this, and we will help build an end-to-end solution. And finally, testing services. And I think this is one of the most important things that I'd like to touch on, because it's very easy to go to someone and say, I want a 50 rack data center, and they can build you a 50 rack data center, and they will hand over this empty data center. It's very key that you make sure that data center is going to do what it's going to do, because as soon as you put your production processes in there, it's vital. You can't do it. So we are very thorough on the testing to make sure that that data center is tested to its maximum capability under all the fault scenarios possible. And it's something we pride ourselves, so that at the end of the day, you will sign off on a fully functioning working data center that you've seen, rather than an empty shell that you're about to fit out. So that's where we are at the moment. We pride ourselves in innovation in IBM, and the fact that we are always leaders and other people try to follow. And just to give you an insight of where you are. Now, I wasn't originally asked to talk about, green data centers. And green data centers mean different things in different parts of the world. In most of the colder climes, when you talk about energy efficient data centers, we talked about how we can use the cooling, how we can use the outside cool air to cool a data center. Obviously, I've learned, having spent my first summer in this part of the year, that free cooling is probably not the greatest sales point in this part of the region. But what I want to talk about is how IBM has successfully cooled servers with temperature which is 60 degrees centigrade. So those of you that know a data center today, the chilled water in data center operates about 7-10 degrees centigrade. we've actually managed to cool servers with 60 degrees centigrade water. Now, as you can imagine, if you can do that, the temperature here is always below 60 degrees, and therefore you can get free cooling anywhere on the planet, any time of the year with this method. And that's a huge saving. 50% of your power bill is from cooling. And cooling doesn't give you any, it's purely a byproduct, it's pure waste. So how it works is the processors, when you actually, if anyone's ever actually touched a processor within the server, you realize it runs very hot. 70, 80 degrees is the temperature that a processor normally runs at. So it's obvious that if you put 60 degree water on an 80 degree component, it's going to have a cooling effect. And that's what we do. And that's how it works, because we get as close to the heat source as possible and allows us to use 60 degree water, and it allows us great efficiency. This also has a benefit in the colder parts of the world, because we can recycle that 60 degree water to use for water heating, for heating of buildings and heating of water. Now, this is something that we've implemented, and I've talked about it. And let me just talk about this. I'm afraid this actually looks like a bit of a concrete building with lots of windows. It's not. It's actually a very magnified picture of a microprocessor in a server. So this is an electron microscope picture. I don't know if you can see it. That small line there is 200 micrometers. And what we are doing with this, and I've seen this in action, is this processor is actually being pumped with water. These gaps that which look like windows are actually slots within the processor. And we have a processor now in IBM where the water, cooling water, actually goes through the processor. And it's something that works. I've seen this, and this is where the next generation is. So as soon as you can do this, anywhere in the world, you're going to get free cooling for your data center, which is a massive implication in terms of the power that you need and the cost that you need to do it. And just to show that some of this is not just in the future and it's not just science fiction, the water-cooled server that I just told you actually runs a supercomputer in Germany. I think it's the largest supercomputer in Germany, and that's running at the moment. So that is somewhere you can go and do, and that whole data center is cooled with this technology. It's with the chilled water, or it's not really chilled water, or the coolant is actually at 60 degrees C. So that gives you some insight to where we're going into the future. So, as I said at the beginning, not many people do realize that IBM build data centers as well as provide all the IT hardware. So just to give you some idea, we've been doing this for over 50 years, and we've built now over 30 million square feet of data center space around the world. And we actually manage 6 million of that. And I think that's a key message, because unlike many other data center builders, we actually run data centers. And because we run data centers, we understand the problems, the pain of managing a data center. And we continually learn from those management challenges so that we hopefully are continually making a better design of a data center. So we pride ourselves that a data center will not only be resilient, but it should be easy to manage as well. And the other element is, we're probably one of the few companies that have an insight to where server technology is going in the future, and we use that insight to roll into the design. So we have a global network of experts, and we work collaboratively as a worldwide team, because we see so many different things across the world that we pool all that knowledge together. So we're continually improving our designs and continually improving our knowledge so that we can use that to benefit our clients. And one bit that I think is quite important here that I should also talk about, we are technology agnostic. And when I talk about technology, I'm talking about the air conditioning, the UPS, the generators. So we don't have any allegiance with a single provider. So we can offer you the best technical solution for your requirements. We are active in the area, but it's a growth area for us. We have done multiple large data centers for some of the ministries in Saudi. I'm not allowed to mention them. In the UAE, we have helped the largest oil company with the design, and we supervise the build of their data center. And we've just won a contract for a leading bank in Abu Dhabi to design and build their data center too. And we've also done a lot of consultancy for one of the leading health insurers in Abu Dhabi. And Egypt, going a little bit further far, probably most of the major banks' data centers have been built by IBM. So just some examples of data centers that we built. This is one in Saudi, just gives you some idea of size, and this is the modular approach. This is a nice clean design where we have expansion here. This shows you totally where the racks will be when it's completed, but we only populate part of this infrastructure at the start, and this will grow as they grow. And just also to show that sometimes we have some demanding challenges when customers give you strange shaped buildings, which you sometimes get in this part of the world, but that's another example of something that we've done in Saudi. So, global player, many data centers we have around the world, and as I say, it's 1,000 of this modular type design we've just done in the last few years of various shapes and various sizes. So, for those of you who understand data center technology, you probably recognize most of these leaders in the area, in the field. And again, we work with all of them. So in all of these areas, we have global relationships. Hopefully that gives us greater purchasing power. So we may be able to help you because we can use our large volume of purchase to get better deals.
Mr. Hare, you have 3 minutes left.
That's fine. So. Thank you. Okay, so that's right in queue. So finally, just in terms of a summary from my point of view, is the key thing I have to worry about now as the data center services leader is the fact that what is going into the data center has really changed. The virtualization and the cloud-based computing has put a completely different requirement on data centers. It's far more dense, it's far more high-powered, and we've got to make sure we design for those capabilities and the scalability that we need. So I'll just finish off that I think the key point that I want to make and take away from this is we will always be innovating. Data centers will always be changing, and hopefully we will always be on the forefront of innovation to make sure that you as potential clients and users always get the best product that you can. Thank you very much.